And what we're going to first do is we're going to go out and look for Golem doing this first release with the brass Golem. And right here in the first, on a single use case of CGI rendering, using Blender and Lex Render scene over the Golem network. Essentially, Golem's project right now in this first release is targeting that audience. We're going to hit this download. We're going to download the Windows version. Once you get this downloaded, they do have essentially a tutorial or a kind of a guide that you can click through. It's pretty easy the way they've done the interface. You can click install from that. This is the Windows binary. So we're going to go ahead and install this. It's a wizard-based install. It does have a Docker dependency, which is going to install itself if you don't already have Docker installed. Docker is a runtime environment, essentially for containerization. And then you have a runtime C++ redistribution requirement in there that the application requires, which anybody mining or putting on a mining rig will probably already have that installed. Hit next on there. It's going to install this dependency. So all this setup is just a package of, it's a scripted package to install various components that are required, not just the Golem network. So it's nice when you have a development team that puts together kind of an install package to where you don't have to go to, 3 different areas to download and install the dependencies. This is all scripted install. So this is going to go ahead and install these dependencies. Now that Docker is going to be something that's going to run in the background. It should also install a virtual machine engine. Here we go. Here's the hooks that it needs to run the virtual machine. And then once this is installed, when it goes to fire up, it's actually all scripted to launch all this stuff right out of the box. And I've installed this now on 2 PCs. I haven't had any issues. So let me go back to here. So general public license, we're going to set those terms. That's the default location that's going to install to, which is fine there. And now it's actually going to install Golem. We're going to go ahead and put that start menu programs. We'll leave those 2 the same. It'll throw it out on the desktop for us. We'll install. We're just going to come up with the verify that publisher. All right, so we're going to go ahead and restart this. The dependencies that get loaded, especially with the Docker piece, you have the Golem mainnet, the testnet, launch Golem's testnet. And it gives you this first warning saying, hey, make sure your computer has a public IP or is forwarded to these ports. Now, this worked without me having to make changes to this, but you can go into your router and make sure whatever local IP this machine has port forwarding to these ports. So it's just a route that you're creating. Here we go. You're going to run on testnet. All the currencies used on testnet have no real value. Got it. All right, so it's going to give you some basic disclaimer information. I want to help Golem by sending my logs. You don't have to choose those, and I'm fine with sharing on this particular one. That's fine. We do not keep a copy of your password. Please write it down. There will be no option to recover it. That's important. Seems like you already have an unlocked application. Enjoy all the features. Please name your node. BBT Test I5. The network tab is where you can run Golem. Set your power allocation and view your earnings balance. The tasks is where you can request computing power from the Golem network, edit task settings, and monitor the progress. And then if you need any help at any time, the docs buttons on the toolbar will be most of your questions and answers. So there, they give you some basics. It's going to ask for a password. And we gave it a basic password. And now it's going through the process down here. So this little menu down here is going to tell you all the things that are going on. It's pulling up the Docker images. Essentially, this is your scripted interface output window, as I would call it. So while that's going there, I'm going to monitor kind of just... If you are into kind of the developer kind of mode, you can go in here and go into developer mode. And then you can see, as it's done a general compute calculation here for us. For this particular node that we're running, this i5 isn't like super fast with Blender, 345 there you can see, and then on Lux and on CPU side. The GPU I believe is not enabled right now on the Windows side. You can set essentially some settings in here. I'm under the settings tab right here, guys, on the right side while we were waiting for the nodes to connect. You can go in there after the benchmark. You can improve the time of the task by setting how powerful the node you are to be connected with, and then you can apply that, and then you can set a base price. So the eventuality of this, and I'll get into kind of a recap of like where this is at and why this this first step is kind of huge of actually getting some content in our hands to where we can start to see the way this stuff can materialize and start to come together. When it comes to general compute, you can see the peers you're connected to and the nodes that you're connected to. You get some basic feedback of the network itself, some statistics under your piece there. Again, you can set a price, and this really comes down, I can see the eventuality where this will be, what's the going rate for the compute. That's going to build that kind of market for it. The docs link right there will take you to the docs. Now, this is kind of what I perused through myself. When you hit this docs, it's going to launch this walkthrough guide of what are the details around this? How does this work? What kind of information do they keep? If you're a provider, what are the risks around that? How do you install? I like how they put the risk ahead of the install. Like before you go ahead and install all this stuff, understand what this node does. Let's see if this thing actually came around now and gave us some Golem. Yep, there we go. Now we have 1,000 Golem. Like I said, if you just wait for a little bit, you'll get it submitted. Now that's equivalent to about $176 on the main net, but this is a test net, so this is not worth anything. But they do give you a little bit to play with. So what we're gonna do now is I'm gonna show you guys how to submit jobs or dragons. Dragons work too. Let's download it. So what we're downloading is a render. The base render file is the Blender. Here we go. Open it. We're going to extract it to downloads. And then what we're going to do is that now gives us a file to create a task to. We're going to go in here to this new task button here, and we're going to choose the folder option. Because usually with these Blender sets, it's an entire dependency tree of content. So we're going to just select that top folder. And then you're going to see it right here that's the name of the job. And then we're going to choose the task type. So it's going to come up and just say name the job. We'll keep it that way. We know that says Dragon and the version number. We'll keep it checked to Blender. We'll hit next. It's check. So essentially it's scanning the folder here, and then it's going to say, would you like to use the file's default resolution? I'll say, yeah, sure, that's fine. And then here it runs a test against all the dependencies. So essentially on a Blender file, you have the different shade, if there's shader pack, if there's textures, the wireframing, all of the content that requires to, render out, it will go through and look for those dependencies. If it doesn't see them, then it's going to come back and say, hey, we're missing some stuff. Now I'm going to go ahead and just say ignore that. I'm going to have it render what it has, but it may make the render look kind of off if it's missing, a PNG file that helps texture something. And that could have been just not included with that file set. But we're going to go in and set a timeout. We'll set it to, now this picked up pretty quick for me before. I just set the timeouts to an hour. And that's essentially just telling the network saying, hey, I'm going to give it a task timeout at an hour and all the subtasks at an hour. Let's see if this thing can, somebody will pick it up. The other thing is how many frames do you want to render? I'll just do 1 through 6 frames. And on this one, you could go GPU or CPU. Let's try GPU. We'll submit this job both on CPU and GPU. So we're going to do it first to just say, hey, any GPUs out there, go ahead and render. We'll pay 1 Golem to have that job done. So that's showing you your bid and then what's the total. So I'm going to say 1, I'm going to pay 18 cents to have that rendered out somewhere. I'm going to hit start on the task. So now it does the deduction here, and then you're going to see it pop up here showing that it's submitted the render job here. While we're waiting for that one, I'm going to go ahead and start the process on the submission for the second one. CPU. And again, we're going to go through kind of a use case more than just rendering Blender files of why this starts to change everything. Okay, so now we got those going. I'm gonna come back over to network where we should, yep, there's the first job. So I noticed that sometimes you have to kind of go back and forth. We see the first job here, having that file waiting for computation. So it's about 27 seconds in, waiting. It's been broadcasted to the network with the file set. So it's a package, it's out there. I'll tell you what, we'll go to the main screen and then I'll talk through this, why this thing's trying to render. So why this is relevant and why do we care? Why do we care that something like Golem exists and that you can use cryptocurrency to pay for it and that it's even a service? Why do we care that's out there? And I think it comes down to exactly what I was saying before. As a content creator, somebody that puts together stuff for the community and the timing of this. So if you look at it, like right now we're doing a live stream, and this live stream will probably be an hour and some change, right? And after this live stream, it's up on Twitch. And I'm going to pull down a VOD file. That's the actual full live stream from this, right? So that's the entire encompassment of what we just went over. I'm going to take a part of that, and I'm going to spend time and effort to cut that up, make references to things, and then render that back out, right? On a video that comes from Twitch, as an example, that could take anywhere from just the production time, couple hours, and then the render, if it's like an hour-long video, that render time, even on a 1950X with a Titan V, it wouldn't matter if it's a Titan V or a 1060. Essentially, the render times are about the same with the GPUs. That output could take 25 minutes, right? And then I got to wait that 25 minutes to, see if I messed up, and then I got to rewatch it and go back in, re-render, and all this activity. So you start doing that, a lot of that kind of activity. Think of that in the capacity from some kind of 3D modeling. Somebody's going to make a 3D model, and the render times on 3D modeling usually is a lot more than just video. Like if you're rendering a scene out, that could be hours. That could be a day if you're doing it on a single computer. So the opportunity to have a piece of software I can download, as easy as we just saw, and then have that set on my desktop, and then I have a small contribution. There's not, setting up account numbers. I didn't have to go through this whole setting up a lot. I mean, I had to put a password in it because I want to, there's the security side of it, right? But I didn't have to have all this other information that was required. They didn't have to have all of this other information about me, right? It's just, I'm looking for a service, and I'm going to post up using a cryptocurrency. They have the trust that the currency and the transaction is going to occur, so they don't need all that other information, because the network and the baseline of the way cryptocurrency works in general is that they can trust in the transaction. So it simplifies the transaction process to where now we can get just straight to the business, right, end of it. The currency side's all integrated into it. So then I can post up against a buy, sell market of available GPUs, and then post out my render job to a network, broadcast it, go on about my business, queue up a whole bunch of stuff, and then it's just popping in all the time. My computer isn't necessarily impacted, right? It just changes everything. I can have the force projection of a world supercomputer in our fingertips. That changes a lot of things. And this is just one. This is Golem just doing Blender rendering right now. But if you're taking this concept in this kind of format and this kind of delivery, you're changing the way a lot of things work, right? They'll just from if this moves on to video, if this moves on to being able to submit securely that content, it starts to change the way we do things, the way content providers can throw stuff out. So that's why I'm covering it. That's why I'm going to play with it right now and trying those jobs out, because I want to see this kind of tech succeed, because it not only disrupts the status quo on some things, but if it streamlines and moves the needle on the way we work and interact as people, and we can get through the painstaking of the repetition of setting up accounts and trying to remember account numbers and all that other stuff, it changes the way things work with it. So it's picked up, you can see that it picked up the other job, and now it's sitting there waiting for computation, and then it'll give us some detail on it. Now this, you can see the status of it right now is that it's out on a node. I can block that person from doing it, but right now he's starting the job, he's downloading it. So now we can see that the job has been picked up. And now we can see the status of that job. So when it's pending and it's just waiting for a node, it's waiting for somebody to pick that job up. So this particular node picked it up. It's now downloading the content. And then you can see the subtask IDs is what it's working on. So as it starts to break that up, and you can see that there's one node that's got it picked up. And if you have a much more complex job, of those picking up the various components of it, if you're rendering multiple scenes, you can start to divide and conquer that way. Which shows you that kind of that activity. So hopefully this won't take too long for them to go through and render that. It's still saying waiting for computation. We can come in here and look at the details of this one. No node active. So this one has not yet been picked up by anybody. So it's showing no nodes that are active on this particular job. And I'm trying to keep it very generalized because I'm trying to separate some of the proprietary stuff that I have to do for what I do from a day job standpoint, and then what I can bring to you guys to help evolve the space, right, in a community side. There's a lot of opponents on blockchain, and there's a lot of confusion on it, and I'm trying to get myself in a position to where I can help better communicate that as a whole, from not just the enterprise side, but just, I bring it to you guys as an open kind of forum, but I'm trying to get into that space where I can start to educate at a larger level from an architectural standpoint, because there is huge amounts of functionality and use cases for leveraging blockchain, IPFS, global compute, distributed computing, trustless environments. That kind of environment stuff is where we really need to go with the entire space in general. So it's going through the understanding of why that matters and countering all of the discussions when it comes to people that have concerns around, like, why wouldn't I just use a database for some of this stuff? The hilarious answers that I can come up with on that stuff is, well, why don't you? First off, that's the number one answer, is like when we start talking about like dev chains like that, like an entire process end to end and scripted and multiple participants, and why this is running. We're just going to go, I can go through something like that. If I go from a dev stack to Git to build and test to regression to deployment to a production environment, what if I had multiple teams that spanned multiple groups in the same company, and they're all using different test sets, and they're all using different software, and there's Microsoft this and Oracle that and all this other stuff. And I then now have to capture any kind of boundary stuff across multiple siloed systems. So at a minimum set, if I had one canonical chain sitting underneath all that I can trust in the transaction, you end up taking that entire concept of a DevOps or a production environment or any application in the entire enterprise stack. It doesn't matter what it is. I don't care if you're selling cars, selling beer, doing whatever, supply chain. It doesn't matter. At the end of the day, if you can cross boundaries and you can take that delegation of trust to, let's say, a series of smart contracts that did that same work, what you're doing is you're divorcing the geopolitical issues between companies, between services, between the own departments internally in a company, and you're giving up that control and orchestration to a controlled environment when it comes to a smart contract, something that's going to execute it without, doesn't care, it's going to do it every time. The reason why you can't do that in traditional databases is because right now I still have to trust a freaking database administrator that works for somebody out of some department or has some kind of other vested interest to be able to do something with some other group or some other company. I want to take that ownership piece of it and the arguments between data and who owns what data and who's the system of record. I want to take all that and say, I still want to facilitate it all, but I want to elevate the processing and the orchestration to where all of us are just participants in it. That's where a blockchain really shines, is if you can execute an order of execution across a canonical process over time, and you can give that trust of execution to a computer to run that smart code that you can audit, the transactions, because of the consensus of the participants that those transactions occurred, right? And you reinforce it with a consensus model and an incentive model of, this is where the bridge between private and public blockchains differ, is that there's kind of a rift of saying that you don't need to have the fiduciary transactional side in it. But what makes the blockchain so powerful in a decentralized way is the fact that you do have an incentive to make sure that there's trust in it, or that you're incentivized to hold a node to trust and validate, and to participate on that network. That transaction, the monetary side, is what helps drive it. So this is the kind of content that I'm talking about. I'd love to bring that kind of content to you guys. I borderline on what I can go through just because of my primary role. And it's not that it's NDA'd or anything like that. It's just I'm trying to find a way to palletize it to where everybody can understand the basic substructures of it. And then you can put in whatever label or whatever company name you want on top of it, right? And then because you're going to have to, this is kind of like the, and I say this in a lot of architecture discussions. I can tell you guys the recipe. I can tell you the ingredients, but it takes a lot to cook, right? And I've said this a few times on this thing. Like that's a recipe and maybe some of the ingredients. But unless you have the architecture background, you have the people that understand on how to put it together, that's the hard part. That's why you have all these ICOs that got a lot of money. And you got smart people, and they've built cool graphics like that. But when you start actually trying to plug that shit together, you end up having a problem, right? Because people architecturally don't know how to really mold it, right? And understand where the value's added. The value's added in that kind of process, not because functionally you can make it happen. And the same thing with Golem, that you can make the fact that you could submit something. It's the divorcing of the trust layer of where I have to now trust in a company. I can trust in the process. Oh, look, we got one finished, boys. See, some of my rants do come out to producing, you know, something. Carter's fired up, cursing. Did I say a cuss word? I might have. Miss BBT's not listening to me. So this took 7 minutes, and then it rendered the job out. Preview. Yep. So see, there's dependencies here. If I click on this detail, it's going to fire up the Golem World Supercomputer, and we're going to see essentially the jobs rendered out. So we can see that there was obviously one of the dependencies didn't have the ability to render out the middle part here. It just still left it a box. So those interdependencies that we were missing obviously did not render that out fully. Like it's still a big box. So that's fine. That was on us. That wasn't on Golem not being able to produce something. There it is, 6 frames. These were all actually the same 6 frames because this was not a moving thing. This was just a static render. You can restart the job. You can delete the job. You can look at the task details, see that it actually had finished. And then this person essentially was the one that received was the recipient of processing the job. So they got paid. You guys can at least see how this thing would work. If you're not into rendering and all that, I mean, you can at least have it and have it running on a machine. And, you know, when this thing actually goes mainnet and you can start to receive Golem for offering some cycle times on your GPUs. So essentially you could download this on like your desktop computer and just let it run and have it sit there waiting to listen for jobs to pick up. And essentially you'd just start getting paid for taking on that job. So that's the setup. When I get back with the team and I can answer some of the more complicated questions, then we can start seeing, you know, what kind of output would this, you know, it all comes down to the buyer seller market. How much is this going to be used? Does it make sense? I think exposure is part of it. I think part of benchmarks against a current desktop computer and some of the more elaborate, you know, i9s, i7s, you know, what's the output of that versus us submitting a job? Is it worth the money to spend Golem for it? Is there a lot of value added right now when it comes to just Blender and, you know, the basic 3D model rendering? Maybe a full scene if we download a full movie or something like that that's open source. There's a few different demo jobs to see how fast that is. We could start to benchmark it. I think that'd be a cool video. I really want to see it not necessarily on a CPU, though. I want to see it working with the GPU, and then we can come back and revisit it. Hopefully you guys enjoyed that. I mean, it was pretty quick. There wasn't a lot. I mean, it's a next finish install thing. So you should try it out. Download some Blender files, send them out there, try to get them rendered. You got 1,000 Testnet Golem to play with. So see what you can render. See if you can get a movie rendered.